friends, today I am discussing about periodic classification. Today's goal is that, and let's know about history. When we talk about history and marvelous inventions, we get shocked.
Let's discuss about a great person, J.W. Dobriner, and he is a German scientist. In 1829, he found some groups of elements which showed similar properties.
The elements are shown above.
And these groups are also called as Dobriner triads.
This states that atomic mass of middle element is the average of the other two elements. For example, average of the atomic masses of calcium and barium is 88.5 and the atomic mass of strontium is 87.5. This clearly states that the above statement is true. Dobriner found that only some elements obeying this rule, but remaining not. So this theorem was failed. And then Newlands comes into play. He is a British chemist. By this time, 56 elements were discovered. He arranged all these elements in increasing order of atomic mass. Every eighth element have properties that similar to the first element. Newland could arrange only up to calcium out of 56 elements known, after which the elements does not show similar properties. After also some new elements were discovered which were not in Newland's theory. Let's talk about other legendary person, Mendeleev. He examined the relationship between atomic masses of the elements and their physical and chemical properties. He believed that the atomic mass of the element was the fundamental property in classifying the elements, and thus created the first periodic table containing 63 elements, till then known as Mendeleev's periodic table. In that, he classified the horizontal rows as the periods and the vertical columns as groups. He thought about future and left some space in his periodic table for new elements. And he named the elements which are going to be discovered as Eka boron, Eka aluminium, Eka silicon. And later, the elements were discovered and fulfilled the empty space. And the demerits of the Mendeleev's theorem are: he have not shown the fixed position given to the hydrogen in the table. And the second one is, at certain places, a element of higher atomic mass has been placed before a element of lower atomic mass. For example, cobalt atomic mass is 58.93 and nickel atomic mass is 58.71. And some elements like manganese are placed with the halogens, even though they have different properties. And one of the merit is he placed the noble gases at a side of his periodic table, which reflects that he does not disturb the remaining part of the periodic table. Later, it is classified as needs improvement. Now let's discuss about the important person in contributing periodic table. He is Henry Moseley, who is an English physicist. He said that atomic number is most fundamental property of an element, but not its atomic mass. He also said that the chemical and physical properties of elements are the periodic functions of their atomic number. Later, Mendeleev's periodic table is classified into modern periodic table. Nowadays, we are using modified periodic table or long form of periodic table. And our next topic in this section is discussing about periods and groups. Wow, it sounds great. And there are total 7 periods in the modern periodic table. The periods are classified as per the element's energy level. And first, let's discuss about hydrogen configuration.
its configuration is 1s1. In the given picture, the 1 in the left side of the S is the energy level of the hydrogen. So it is placed in the first period of the periodic table. And let's discuss about helium. And its energy level also 1. So it is also placed in the first period. And the elements like lithium, boron, carbon, nitrogen and oxygen are placed in the second period as their energy level is 2. The first period contains two elements. They are hydrogen and helium. And the first period is known as the shortest period among all 7 periods. And the second period contains 8 elements and third period also contains 8 elements. So these are called short periods. And the fourth and fifth period contains 18 elements each. And these are called long periods. And talking about sixth period, it is the longest period among all 7 periods and it contains 32 elements. And the 7th period starting with the number 87 is incomplete and consists of 19 elements. In this way the periods are arranged. Let's talk about groups. The 18 vertical columns are called as groups, and the elements belonging to a particular group is known as a family. Apart from this, some of the groups are given typical names as exemplified beneath. And the elements of group 1 are called as alkali metals, and the elements of group 2 are called as alkaline earth metals, and the elements of group 1 and 2 represent basic nature. Let's talk about nicogens. Oh, sorry. They are also called as group 15 elements. And the elements of group 16 are called as chalcogens, and the group 17 are called as halogens. Group 18 are called as noble gases or aerogens. Some important points about periods and groups are: in each period, an element starts with S configuration and ends with S2P6 configuration. Each period except first period starts with an alkali metal and ends with a noble gas. For example, let me take the example of first period. In the first period, hydrogen is the starting element. Its configuration is 1s1. And the last element in the first period is helium, and its configuration is 1s2. As I mentioned earlier, except first period starts with an alkali metal and ends with a noble gas. And each period starts with a new principal quantum shell and ends with the same shell. Now let's make a note of periodic properties. The properties which are directly or indirectly related to their easy or electronic configuration means the periodic properties also depends upon the element's electronic configuration. And when we move from left to right or right to left in a period, or top to bottom or bottom to top in a group, the chemical properties or physical properties varies. For example, sodium lies left to a period and the element chlorine lies to the right of periodic table. Even though they both belongs to the same period, why they varies in their properties? The answer is because of periodic properties. I will explain answer to this question after explaining the periodic properties concept. Now I am going to discuss 3 important points about periodic properties, and the first one is
atomic volume, atomic size, melting point, boiling point, and density are important physical periodic properties. And the second one is electronic configuration, ionization energy, electron affinity and electronegativity, metallic nature, oxidation state reduction, etc. are important chemical properties. And the properties like specific heat, refractive index are not come under the periodic properties. Now let's discuss each property interestingly and clearly and briefly. And before, I want to explain four important effects. They are screening effect, nuclear charge, stable configuration, penetration effect. And the first one is screening effect. For example, let me take a atom of 3 shells. The screening effect is the phenomenon in which the penultimate shell means n-1 shell. For example, this is the last shell. Let it be n, and the n-1 means this shell. This is called penultimate shell. And this penultimate shell acts as shield or screen between nucleus and valence shell. This screen or penultimate shell decreases the nuclear force that is applied by nucleus on last shell, and this effect is called screening effect. And if more closer the penultimate shell to the nucleus, then the shielding effect is expressed more, and more electrons in n-1 shell or penultimate shell, then more shielding effect. These 2 points comes under notes. And the second one is nuclear charge. Coming to a nuclear charge, as I explained before in the example, nuclear charge or nuclear force is the force that is applied by nucleus on the valence shell. If more the nuclear charge, then it is difficult or uneasy to remove the valence electron, as it is held tightly because of nuclear charge. From this, we can conclude that nuclear charge is inversely proportional to screening effect. As more screening effect, then it is easy to remove valence electron. Then if low screening effect, then nuclear charge.
Next one is stable configuration. Stable configuration means half-filled or completely filled subshells possesses extra stable nature. For example, nitrogen also exhibits of stable nature. Its stable nature is because of the half-filled electrons in its subshell, outer subshell. And coming to the neon, it belongs to the stable group in the whole periodic table, that is 18th group. And neon has stable configuration 1s2, 2s2, 2p6. The configuration ns2 and np6 in the second shell represent stable nature.
Thanks for watching, friends. We will meet in periodic classification 2 in my video. Thanks for watching. Please subscribe my channel.